In previous mathematics courses, you have studied exponential functions. In this section, you will need to graph several exponential equations and compare their graphs. The best way to do this is to create a table of x and y values, then plot these points. Since the domain is specified, you will know at what points your graphs will begin and end. For example, graph the exponential equations y equals 3 to the x over the domain -2 less than or equal to x less than or equal to 2. Let's start by making a table of values for our function. Once we have created the table, we can plot these points to draw our graph. To evaluate exponential equations like y equals 2 times 3 to the x, you first need to evaluate the exponential factor by raising the base to the power represented by x. Then multiply by the constant factor, and remember correct order of operations. In the task you did today in class, log logic, you learned about the relationship between exponential functions and logarithms. Using this relationship, you were able to use the definition of logarithms to help you switch between logarithmic and exponential equations. Hopefully, as you did so, you became more comfortable with logarithms and what they mean. Remember that the definition of a logarithm is this: for all positive numbers a, where a is not equal to 1, and all positive numbers x, y equals log base a of x means the same as x equals a to the y. Note that the base of the exponent and the base of the logarithm are both a. In problems 7 through 9, you will examine this definition and explain why each part of the definition is important. As you do so, you may want to consider examples and counterexamples. Rewrite these examples in exponential form and see if they still make sense or not. Also, remember to try a wide range of exponents, including rational numbers, to see if your examples still work out. You can also try graphing the logarithms to see what happens. You will use the definition of logarithm to rewrite exponential equations in logarithmic form for problems 10 through 16. Here is an example. Write the following exponential equations in logarithmic form. 3 to the power of 5 equals 243, and 2 to the power of -5 equals 1 over 32. Using the definition of a logarithm, we know that x equals a to the power of y can be rewritten as y equals log base a of x. Notice that the base of the exponent is the same as the base of the logarithm. Therefore, for our first exponential equation, since the base is 3, we know the base of our logarithm is also 3. Next, notice that the answer to the exponential equation is the input of our logarithmic expression. Using this information, we can rewrite the exponential equations as follows. 3 to the power of 5 equals 243 becomes log base 3, 243 equals 5. 2 to the -5 equals 1 over 32 becomes log base 2, 1 over 32 equals -5. As you work through problems 17 through 21, consider the logarithm in exponential form if you are having trouble finding an answer. Previously, you have used properties of exponents to rewrite and simplify expressions. In this section, you will use these properties to write expressions as either an integer or a simple fraction. Here are some of the properties of exponents you have learned about. A raised to the power of 0 equals 1, a to the negative b equals 1 over a to the b, and 1 over a to the negative b equals a to the b. A over b, all raised to the m, is the same as a to the m over b to the m. And a to the m to the n is the same as a to the mn. As you work through problems 22 through 30, use these properties to simplify each expression. Also, remember to consider order of operations. Here are some examples. Write each expression as an integer or as a simple fraction. 4 times negative 19 to the power of 0. Remember that with order of operations, we focus first on the exponent, then we multiply the numbers. Also remember that negative 19 to the 0 equals 1, since any non-zero number raised to the 0 power is 1. So, 4 times negative 19 to the 0 is equal to 4 times 1, or just 4. For the second example, 12 to the negative 1 over 4 to the negative 2. Remember the property that negative exponents move numbers from the numerator into the denominator and vice versa, since they are used to represent taking the reciprocal of a number. We first focus on the negative exponents, then we will simplify the fraction. So, 12 to the negative 1 over 4 to the negative 2 becomes 4 squared over 12 to the power of 1, which is equal to 16 over 12, or 4/3.